When working with equations, one of the key features that you might want to see on the graph is the x-intercept. The x-intercept is the point on the graph where it intersects with the x-axis. Now, any point on the x-axis is going to have a y value of 0 because we're going to go to the right or left by some value, but we're not going to go up or down any. So for example, if I'm looking at a graph that looks like this, you can see that we actually have 3 x-intercepts, one here, and one here. And those values, from the origin, we're either going to go to the right, or to the left, or to the right, but we're not going to go up or down, so we know that the y value is going to have to equal 0. So any of these coordinates are going to have some value for x, and then a y coordinate of 0. So when we're working with an equation like this quadratic equation that's given to us in vertex form, we can find the x-intercepts by using this property that the y value is 0. So the first thing we're going to do is we're going to substitute in 0 for the y value right here. So 0 equals -1/2 x minus 3 squared plus 8. Now, sometimes students have trouble figuring out, well, what do I do first when I'm solving an equation for a variable? And in this case, we need to solve for x. Well, a nice little trick we have is our friend PEMDAS. Now, normally when we're using PEMDAS, we're simplifying equations. So when we simplify equations, we start at the top and we work our way down. When you solve an equation, all you have to do is undo the order of operations by working backwards. So going backwards in the order of operations helps us solve equations, and going the regular straight way for the order of operations will help us to simplify an expression. So in this case, we're solving an equation, so we're going to start at the bottom with any addition or subtraction that we need to undo. Now, I do see a -3 in the parentheses here, but that's exactly where it is in the parentheses. And if I'm going backwards through my order of operations, parentheses comes last. So I don't want to worry about the -3, but I do see this +8 out on the end here that I want to get rid of. And we have to undo. So undoing the order of operations means I have to undo +8. So undoing +8 would require me to subtract 8. So I'm going to subtract 8 from both sides of the equation. That will give me -8 equals -1/2 x minus 3 squared. Now, going through my order of operations backwards or in reverse, I don't have any more addition or subtraction I can take care of. So now I'm going to move on to multiplication and division. Now I notice that I'm multiplying right here by -1/2. Now I could divide by -1/2, but dividing by fractions kind of looks funny. So instead of dividing by the fraction, I'm going to multiply by the reciprocal of -1/2. And the reciprocal just means you're going to flip the fraction over. And so I'm going to multiply by the reciprocal, so that means it's going to be 2/1. And if I multiply on one side of the equation, I always have to remember to balance it by multiplying the other side of the equation. So now what happens on the right-hand side is my 2 will cancel out. The 1's we're not too worried about because 1/1 is just equal to 1. And my negative times negative will give me a positive. So now that value out in the front is just simply a +1. And we don't usually write the +1. So it essentially goes away. So now we have x minus 3 squared on the right-hand side. And we just need to simplify the left-hand side. So I have a negative times a negative, which is a positive. And 2 times 8 is 16. Now I don't need to worry about the 1 on the bottom because 16 divided by 1 is equal to 1. So now I'm finished with the multiplication and division in my order of operations, so now I need to undo any exponents in the equation. To undo a squared, we're going to take the square root of both sides. And taking the square root of both sides, we have to remember that there's actually 2 possible solutions. When we square root 16, we could either have a positive value or a negative value. So don't forget to write the plus or minus out front. Now the square root of 16 is 4. But again, we have two answers. It could be a positive 4 or a negative 4. On the right-hand side, the squared and the square root undo each other, and so we're left with x minus 3. So now I actually have two different equations that I can write. I have a positive 4 equals x minus 3, and I have a negative 4 equals x minus 3. And solving those two equations, we're going to add 3 to both sides here, and that will give us that x is equal to 7. And the equation on the right, same step, add 3, and we're going to get negative 1 equals x. So we have two x-intercepts, and the x-intercepts, when we write the answer, sometimes you'll see it written as just x equals 7, comma, negative 1, meaning x equals 7 and x equals negative 1. So you could also write it out separately that x equals 7 and x equals negative 1. Sometimes we also see them written as ordered pairs. The instructions on this problem said to state the coordinates. Anytime I see that word, the words coordinates, I want to think x and y. So we know that the x-coordinate of this first point is going to be 7, and we know from our original statement up on the top right that the y value is 0. That's what we substituted in to get 7. And then similarly, the x-coordinate over here is negative 1, and the y-coordinate is still 7. So we have the x-intercepts of a quadratic equation when it is given to us in vertex form.